So we're going to launch this session of Powered by AI. Powered by AI is a conference series that we started a month ago, and we'll just briefly talk about it. And to moderate this panel is Andrea Bernard.
Thank you. Hi, everybody. I'm Andrea Bernard. I'm the Managing Director of NG Digital, which is NG's own entity that focuses on developing software for our purposes, so IP that is owned by NG, and also for digitalising and accelerating the digitalisation of NG more broadly.
And I am Mihir Sarkar. I'm Head of AI at NG Research and Innovation, where I lead a program called Breakthrough AI, which has for objective to accelerate the impact of AI on the business transformation and operations. So for this series of conferences, the goal is to really create a community around the topics of AI and the energy transition and sustainability. So the first session a month ago was about collaboration between humans and machines. And we have the second session about AI startups that have an impact on the energy transition. So we're happy to welcome 4 startups today.
Fantastic. So we will welcome Laurent from SAMP. Come on down. It's like a game show. Thank you, Laurent. Do you want to introduce yourself and tell us a little something about SAMP?
Hello everyone, so I'm Laurent, the co-founder and CEO of a startup called SAMP. And at SAMP we help modernize existing facilities of NG and other big groups using 3D and AI to reconnect automatically the technical documentation, which is rarely up to date, with the reality of the field with 3D scans. And that's accelerated by a factor of sometimes 10, the speed at which you can modernize a facility and go to the energy transition.
Thank you. We've got Laura from Upstream Tech.
Hello everyone, I'm Laura Reed from Upstream Tech. My role is head of product strategy, so I work between our go-to-market team and our technical team to build our roadmap. And at Upstream Tech, we provide state-of-the-art, cutting-edge technology solutions to help with environmental challenges and climate risk.
Great. And welcoming Gus from Raptor Maps. And Raptor Maps is a fantastic startup. Tell us about it, Gus.
Thank you very much. My name is Gus Capace. I lead our growth strategy team at Raptor Maps. So principally, I sit between commercial and product to develop new solutions and then bring those solutions to scale. But Raptor Maps is a software company focused in the solar sector, enabling our customers to continue scaling their solar portfolios in a safe, efficient, and standardized way. So we collect data using robots, ground robots, or drones, and that data is then analyzed by our model, which then produces analytics for our customers to then make actions on.
Thank you. And you've got Don from QAC, which is a Techstar Sustainability Paris startup.
Hi, everybody. Nice to see everybody out. My name is Dawn. I'm the Chief Innovation Officer and co-founder of QAC. We are a startup out of Nova Scotia, Canada, and we are leveraging AI to give companies the business intelligence they need to decarbonize. And we do that by taking the guesswork out of the financial business case for a range of low carbon options.
Thank you. So we'll kick off the discussion by with a few questions to understand how each of these startups thinks about applying AI to the energy transition in different ways. So I think what we can do is give a few minutes to everyone to introduce a bit more in depth the startup, how you think about AI in terms of the impact it has and the value proposition of the company.
Yep, great. Happy to start. Thank you. So when it comes to energy transition, there are several aspects to it. One that comes to mind is usually adding more renewable to the mix, which is great. But there's also this big topic about how do we modernize existing infrastructure, existing facilities. And that's what SAMP is all about. We help these facilities, so dealing with the storage of natural gas and LNG terminals and district heating, district cooling, to modernize faster. And to do that, we leverage artificial intelligence in a very specific way. We start from a 3D scan of the facility, which gives you the reality of the field as it is today. And our AI makes sense out of it, which means it automatically finds all the equipment in the 3D, your pipes, pumps, valves, and links that to your technical documentation. And at the end, what you get is what we usually call a digital twin of your facility, but directly anchored in the reality of the field. So AI is the way to accelerate this process and make sure you can do all your modernization projects or your maintenance activities much faster and safer. So for us, energy transition is all about making sure that these old facilities, sometimes many decades old, can decarbonize and transform much faster, leveraging AI to empower all the workforce to do their work much faster and more efficiently.
Thanks. So at Upstream Tech, our product Hydro Forecast is a hydrologic model that helps energy utilities and others that are managing water more efficiently understand how much water they're going to have in their facilities so they can understand how much power they can generate. And as we talk about the energy transition, we have wind and solar coming on. Right now, the battery storage is very limited, and so hydropower is that base load, and understanding how much you're going to get in the next days, weeks, months ahead can help you plan better how much energy you're going to have available for bidding, for using, how much you may need to purchase to make up for that deficit if there is one. So at Upstream Tech, we're helping where you have an AI-driven model that is more advanced and more accurate than what's out there right now to help with predicting how much water you're going to have at your assets over the next days, months.
Awesome, thank you. When we're talking about the energy transition, obviously solar is one of the primary sources of energy that's continuing to grow year over year. So within the sector, there's hockey stick growth year over year in how much solar is deployed, but at the same time, labor is staying quite consistent. So it's becoming increasingly difficult to continue operating these growing portfolios with the same labor force that exists today. So Raptor Maps aims to bridge that gap with AI-driven decision-making tools. So whether it's an underperforming panel that needs to be replaced or erosion that is occurring in a far corner of a site, we bring that decision and that data to back that decision to the operator so they don't have to send someone hundreds of miles away to go and fix that issue. So all about giving them the data they need to know what they have to fix, why it exists, and how they can mitigate that risk moving forward.
Myself and my co-founder have been in the sustainability field for over 25 years, and we've worked with thousands of companies trying to embed sustainability into their operations. And we really understand what stops companies from taking action. Number one is they don't have the internal expertise to understand what their options are, how much it's going to cost, and how much carbon emissions it can reduce with each option. And so we saw an opportunity to leverage AI and machine learning to disrupt the consulting business model, which isn't scalable, to provide access to this type of business intelligence at scale. And we've had a lot of really positive response. We just launched our early adopters program last week, and very excited for what the future holds for us.
I think I've said enough about me, but one thing to call out is NG Digital is in part a collection of software platforms that have been built over time, and one of them you can visit just over there. It's called Nemo, and it is a really fundamental product for the running of district heating and cooling networks. Mia.
All right. So we'll start with SAMP, dig a bit deeper into the solution, especially in terms of how you consolidate technical documentation, how do you create your digital twins, in terms of what are the data sources that you input, and how do you think about integrating physical models, your digital twin, and operations?
Yep. So just to picture the facilities we work with, they're typically 20, 30-year-old facilities, and they consist of tens of thousands of individual pieces of equipment. And they're constantly being modified by many stakeholders, usually contractors. So you can imagine that they're quite different from what they were 20, 30 years ago in the design stage. And the data lags behind. All the technical documentation, meaning the procedures, the schematics, the diagrams, the 2D floor plans, most of them are irrelevant or at least not updated. So running AI on top of that, and what some people do is try to make sense out of this data, but garbage in, garbage out. If you feed your data with outdated technical data, your AI, not much will come out of it. So the only thing we trust at SAMP is the field itself. The field is the only single source of reliable truth. So we start from the 3D scan, which represents the reality. And we have trained our deep learning models to automatically detect these equipment and build inventory. And then we have a graph approach, to go a bit technical, that identify the gaps and maps exactly what you have in the field with what you thought you had in your documentation. And all these gaps we typically find between 10, 15, up to 30% discrepancies between the two. And what that brings is a reliable model of exactly what you have today in your facilities with added data and intelligence on your 3D reality. And that opened many doors to what we usually call Industry 4.0, of all the predictive models that you can have, all the assistance to the workers on how to do this procedure, and so on. But to do all that amazing tech that you can build on top, what you need first is the foundational model of exactly what you have today in the field. So this is why we build AI really starting from the field reality.
In terms of usage, do you mostly deal with operations or simulations for changes in the factory or the design of the system, greenfield development and design? What are the use cases that you specifically work on?
The main use cases we work on is maintenance and modernization. And our product is called Shared Reality, and I think that's quite self-explanatory. We share the reality of the site to all the teams. And so that's the core business on existing facilities to accelerate that. And we're going more and more towards engineering and design of what's called revamping, so big modernization projects of facilities, which require reliable data as what it is today before you can modify the facility. So give more time for the engineers to modernize the plants rather than doing documentation, because that's what the world needs is engineers to do engineering and not documentation.
And the main purpose of modernization is sustainability, right?
Yeah. Decarbonization and reducing the environmental footprint. So moving to biomass, doing hydrogen retrofit, and every single facility on Earth will go through some sort of modification like that in the coming 5 to 10 years. So we'd better get ready for it.
What are the biggest challenges in terms of implementing within a customer site?
The main challenge that we face is trust. People don't believe it can work. So we have to prove to them that yes, it does work. You can run the AI and it will find it's quite disruptive. And so we have to have proof point and show it on their data set and do a run pilot to tell our customer that yes, it does work on your facility, and then we can scale. It's really the trust in the AI that we have to build within the community as a whole.
Thank you, Laurent. A question for you, Laura. Upstream tech obviously helps forecast and remotely monitor river flow, and I think we can see the link between your technology and environmental sustainability, specifically in the management of one of our most valuable resources, fresh water. But how do you explain the role that upstream tech plays in driving environmental improvements and sustainability?
Yeah, thanks for the question. So our mission at Upstream Tech is really to use data for good. And so we have applied narrow AI to solve a very specific problem, which is forecasting hydrology. And what's kind of amazing is that we've been using the same type of hydrologic models for the last 50, 60 years, kind of adding things on to help them with extreme events or climate change or changes in precipitation, changes in temperature. And when you compare what's been built there with what we've managed to build using a totally different way of understanding hydrology and forecasting it, our model is more accurate, it's easier to experiment with, so you can include more inputs, you can test out a new data source, you can go to a new place, and it doesn't take near as much time or resources to build that new application. And so what that affords the energy community and others that are managing water is more time and more confidence in what they're going to be getting in their predictions so that they can use that information to make really, really important decisions. And that's the part we don't do. We hand over the forecasts and we are able to explain them and help our customers use them. But at that point, the hard things are on them. Do they release water ahead of a big storm? Do they market that power and say that they're going to have it before, so they don't spill or things like that? So we are committed to helping with the energy transition, and we think that our product is well suited to elevate hydropower as one of those solutions, because even if we're not increasing the amount of hydropower on the market, that amount that's there right now is serving as a really important base load as lots of utilities around the world are stopping their gas and coal and trying to transition to more wind, solar, and water.
So you talked a lot there about how you use the data and you can do all of this much better, easier, faster, more accurately with AI. Have you run into any challenges around the trust people have in that data and its accuracy?
Yeah, I know. I made it sound really easy. I'm sure that didn't pass the sniff test up here. I would echo the garbage in, garbage out. So a model is only going to be as good as the data that you're able to feed it. And so we have a pipeline where we pull in a lot of data from global weather forecast models, satellite data, which is very noisy if you have clouds and things like that. And we process that data before we ever show it to our model. One of the challenges that we have is customer data. So if you have a reservoir where you're trying to measure how much came in, observed flow, it can be very noisy because that's not a direct measurement. They sort of use different things like elevation and storage, and they estimate that inflow. And so we have to clean that before putting it into our model. And I would say trust is another thing. What's kind of been interesting as we've grown in our customer base is at first people were really scared of AI and ML, especially in hydrology. They thought that was too much of a change. But as people have started to use our model, and more groups like NG and others have built on innovation, they want to digitize, they want to be the ones that are pushing the field, we've actually seen folks more gravitate toward us because we are helping them become AI solutions and sort of use the latest advanced technology. So I feel like there's a bit of a shift, even if we still have folks that we need to prove their trust.
And I think your model is interesting also because, as you said, it incorporates physical models of water flow with AI and machine learning techniques. Can you speak a bit more about that, about the technology behind it?
Yeah, sure. So the group of people that help build this model are scientists, subject matter experts, also with machine learning together. So basically the combination of that ensures that we're not building a ML model that's going to go make a crazy prediction or do something that's not physically plausible. And that's really important for hydrology and having the trust of our users. So we've built into our process a way to physically constrain our machine learning model so that it learns hydrology in a fundamentally different way than it has in the past, but in a way that's ensuring that it won't make predictions that aren't reasonable and physically plausible.
Thanks. Gus, will move on to you and Raptor Maps. So it's a platform that helps with solar site management. Can you talk a little bit about how it helps in terms of value proposition for resiliency and also increased yield in terms of solar performance?
Absolutely. So as Mihir mentioned, Raptor Maps focuses on single site, but also portfolio solars. So there's two components to that. There's the actual asset performance itself, right? Is it performing in line with expectations or way below? But then there's the underlying issues that might be causing that around equipment health. And if you don't have a good view of equipment health or what specific components are on your site and might have risk of certain issues, it's really difficult to make very resilient systems that will be there when you need the power back online. So Raptor Maps helps identify what issues exist and, more importantly, how you need to go about resolving them. So if there's a serial defect that might be happening on one of your regions, you then have the data on your hand to know exactly how much it's impacting power generation and how you can mitigate risk around that issue moving forward and maybe avoid that type of equipment in that type of region. So that's just one quick example.
So can you explain the data capture side from the drone's perspective and then how that is analyzed later for post-processing?
Absolutely. So there's two ways data is captured by Raptor Maps. The first is a manned flight via drone. You can see it over there on our booth. So that's someone on the site flying, collecting both thermal and RGB or Roy G. Biv imagery. The second, and much more interesting and what we're excited about, is a nested drone that lives on site. So the first requires a human to be there, and then you have a time constraint. They're only going to be there for 8 hours a day, so if the site's super large, you have to keep coming back to collect that data. But with a nested drone, that can fly hourly, daily, weekly, almost nonstop, because it'll come back to the dock, charge, and then you have that almost constant data stream coming in of both thermal and color imagery, allowing you to have a really strong view of how your asset is performing, not only at a point in time, but over the course of a year, allowing you to track degradation or track any issues, or even better, post and pre-storm, which I know is a big issue in the United States, where a hailstorm will hit, but they'll have baseline analytics before the storm, post-storm, and they can measure the difference between the two and really understand how much their system is impacted.
Do you have a specific example, for example, for where we can combine Raptor maps in terms of capture of images, aerial images, with SCADA data, for example, that comes from other sources, with maybe robots on the ground that can also do visual inspection? How do you combine all those? How would you combine all those sources to make informed decisions about maintenance plans and better performance?
That's a really great question. So for context, all solar systems have a SCADA and a DAS system. That's essentially just how much power your system is producing. And those have sensors and alarms on each inverter block. So it's a common knowledge in the industry that those alarms and alerts go off all the time. And it often requires a human to go to site then to investigate that alarm. So with the integration of our robotic system and those power generation systems, when those alarms go off, leveraging our digital twin and the localization of those alarms, the drone can automatically deploy, go scan the area that the alert came from to determine if there was an issue causing that alarm. That is all done via our AI model, and it really gives owners the ability to then not have to send someone to site, which could be hours away, especially in the US, like I mentioned.
And what I find really interesting is that we can combine different tools within the ecosystem. And in particular, we have some developments in the Breakthrough AI program that complement some of the use cases to track, for example, the position of trackers that may be off compared to what they're supposed to be.
Thank you, Dawn. So tell me, when was Accuracy set up?
We actually had the idea about 2 or 3 years ago, and myself and my co-founder both are mature founders. So I was in the middle of my PhD, and my co-founder had her own consulting firm. And so we weren't really sure if we had something that was worth blowing our lives up for. So it took us a little while to figure out that this thing actually had legs and that we should really just go for it. So we actually really started working on our MVP about 12 months ago. And since that time, we've just accelerated our progress. We've done extensive customer discovery. We've had a lot of interest. And we're here with Techstars. We're one of the Techstars Sustainability Paris cohort, and also with Scale AI through Canada. We're part of Canada's AI delegation. So we've really had a lot of success in a very short period.
Yeah, amazing. So Accuracy helps businesses find insights or helps them find low carbon opportunities. And obviously, if you've been around 12 months, you are AI native, and maybe even Gen AI native, I'm not sure. But tell me, what role does the AI play in actually generating those insights and opportunities for businesses?
Absolutely. One of the barriers that companies face, of course, is getting accurate data, getting the right data to be able to identify those low carbon options. And the data that we needed to run our algorithms was disaggregated across the internet. So in publicly available government documents, academic literature, industry white papers. And so before AI, we would have had to hire a whole bunch of carbon analysts to parse all that data, clean the data, and then embed it into our algorithms. And I don't know if you've tried to hire carbon analysts recently. They're like a unicorn. They don't exist. There's just so much demand for their skill set. And so we realized that we could actually overcome this barrier by building a domain-specific large language model that allows us to contextually data mine the data that we need. And so we successfully built an LLM, and right now it's a semi-supervised process. So we still have someone on the back end, a carbon analyst, looking at the data, cleaning it, verifying the validity, and making sure that it's good quality data. But that was a game changer for us that really accelerated our journey. We also built machine learning, of course, into our algorithms so that as we get more users on board, we can actually harness that primary data to improve our recommendations and our output.
And can you give me an example of how that output or those recommendations is helping companies drive a sustainability shift or a low carbon future?
So one of the barriers, of course, that companies face is that they assume that decarbonizing is going to be too expensive. They're like, oh, it's either switch to EVs or get solar panels, and those are both really expensive. We can't afford to do that. And so what we reveal through our analysis is that there are very, very many low carbon, capital efficient options available that we can tailor specific to their operations. So things like preventative maintenance, shutting down your compressors on the weekend when you're not operating, increasing boiler insulation, reducing leaks in your boiler system. All of those have a very low capex, very quick payback. And so it really dispels the myth that companies can't afford to take action. And so they can get started right away with those options. And the higher capex options, they can build their budgeting plan so that they can tackle those in the future. So we're really starting to help them understand that they can actually respond to the pressure that they're getting from their customers, from stakeholders, regulators, to show that in good faith they are making strides and plan their road to net zero.
So I'm interested in following up and opening up the discussions a little bit about the intersection between AI and the energy transition. So AI is obviously a huge field. So you mentioned about the motivation to get into a startup that was focused on sustainability. I'm curious to hear about the motivation of each of you as part of this, the startups either that you founded or that you joined later on, and how that is the intersection of both is an option that's attractive to potential talent in terms of joining the company.
Well, as not a co-founder, I can speak on behalf of our co-founders at Upstream Tech. So our two co-founders were computer science, machine learning background, and at first they worked in sort of pure tech. They worked for Twitter, and they worked for a little startup that was bought by Twitter. And when that happened, they sort of took a look at themselves and starting to have a family and said, I think I can do something else with these skills. And so that was sort of the beginnings of Upstream Tech. And from there, they sort of went and talked to academics, actually, folks that are in the sciences, and said, what are the biggest challenges? Didn't take long for someone to mention water. As we all know, water is a very precious resource and very limited in some places, and you have too much of it in other places. So that was sort of how they started in the water area. And from there, really attracting scientists, and actually one of our co-founders, he's an avid climber, and so he would go to the climbing gym and see who was there and attract folks from the financial sector. So we have one machine learning engineer that used to do statistical financial modeling. We have subject matter scientists that have come from the government before. And so we've sort of compiled this team of folks that have really strong scientific skills, natural resource minded, and put together a team that's sort of all under this mission of trying to build AI, but do it in a way that's trying to improve the planet and our sustainability and footprint.
maybe on my side, just to add to that, there's one word that I think summarizes everything here is impact. Recently, we did the exercise within SAMP to define our core values within the team. And the first word that came up was impact. And impact had really two meanings. Obviously, data for good is something that's positive for the planet, for people, but also impact that is difficult to have when you're in a big corporation. Your individual impact, I mean. In my career, I've worked for several big players, and it's difficult to measure your own impact within a big company. So when you are in a startup and you know that every single decision you make every single day has an impact on the company, and the company has an impact on the world, that's the best motivation you can have every morning, I guess. So, and that's I would say the common thread between all the team members is, and it's becoming a core value for us, how to make sure we have impact at scale and to wake up every day to achieve this mission.
Yeah, I'll just definitely pile on to that from Raptor Maps example specifically. I'm also not a co-founder, so I join you there. But when I joined the company, it was much smaller, and impact is definitely something that sticks out to us as well. And what's interesting about Raptor Maps is that it's at the intersection of all these super interesting and top-of-mind topics with solar, specifically as a technology, AI, and then also just a software platform for an industry that's historically been quite manual. So all those put together are just creating perfect recipe for tremendous impact across the industry. And it only gets better as the industry continues to scale as well, and more folks begin to adopt digital tools such as ours.
And as I mentioned previously, myself and my co-founder have really dedicated our careers to sustainability. It's something that's been very important to us. And, Allison said one day, we've spent the last 25 years talking about the why for cutting carbon and sustainability. We can't spend the next 25 years on the how. We don't have time. And so that really incentivized us to start this and go out on a limb and, as I said, blow our lives up and see what happens. So sustainability is core to us. And we also did an exercise on day one where we each individually listed our own values and vision for our company. And they included inclusive leadership, Indigenous reconciliation, and impact. And that's something that really resonates with our employees, especially when you're a startup, you can't afford all the bells and whistles to give your employees all the benefits and high salaries compared to a lot of our competitors. And so when we ask our employees why they joined us, they really, really just align with our mission, and that's actually amazing.
Instant employee engagement, it sounds like. And thank you for all of those who have stuck with us, because Elon Musk is on the main stage. Don't leave. We have some more interesting conversation to have. And here's another question for the panel. When you're at the intersection of many workflows, business processes, and perhaps technologies, what role, if any, do partnerships play in making your businesses successful? Gus?
Yeah. Oh, was that targeted? Okay, great. I'd say they're crucial, especially early on when there's so many iterations of your products, and right alongside the industry is evolving as well. Global partnerships such as we have with Engie are critical. It gives you reach into regions and teams that you historically wouldn't have access to. But in addition to that, it also gives you a partner to innovate with, to test new ideas out. And then lastly, it allows you to understand how market leaders are thinking. Like, what are the challenges that are keeping them up at night? What are the trends they're seeing? All of this we can then take as a smaller company who's a bit more flexible and can move a little quicker and adjust our strategy to fit those trends and challenges that are affecting them.
Great, thank you. Laura, anything to add?
Yeah, I mean, that was a really good answer. I think what I would add to that is, for us, partnering with an organization can mean helping them achieve a goal where we're a part of that. So specifically with Hydro Forecast, we do river forecasting. We give flows, and that's what we're focused on. And there's lots of groups that want to do flood modeling, or like a utility. They want to take our river flow forecast and put it into a power generation model, something that we don't do. So we find ourselves as an input and a partner in lots of other things that require what we do, but is not something that us as a small startup is able to or interested in doing all those different things. So we really want to stay focused on the products that we're trying to build and improving.
Maybe just to be a bit provocative here, I would say last week I had a call, a very interesting call with the CEO of one of our almost direct competitors. And yet, we believe there can be a partnership between our companies. And when you're driven by impact, what we mentioned before, it doesn't really matter, okay, who wins, who loses. And it's, I recommend a book actually, by the way, but Infinite Game. We're playing an infinite game. We're here to make things progress, the industry progress as a whole. So it's not about, okay, who has the best startup, who's more profitable than others. So partnerships, even with your competitors, can make sense in some cases. So I shouldn't say that in front of the corporate VC of NG, I understand that. Yet, I think there's bigger things at play than money, and we are definitely here for the long game, and the infinite game, and partnerships are all about that, I guess.
Thank you. Dawn, anything to add?
Yeah, I would say for an early stage startup, it really gives us legitimacy and reach. As an early stage company, we are looking for companies to utilize our solution. And having big names behind us really sort of reduces that risk in their eyes. So we definitely, we're very pragmatic about not having to build what other people have built. We don't, we currently generate a company's scope 1 and 2 emissions as part of our platform, but we don't have to. So if a company already uses carbon accounting, we're going to build out APIs that we can plug directly into our solution and then push out information to carbon reporting. We really sit in the middle, and that's our niche. So we see the opportunity for partnerships at scale, and we're really excited to talk to potential partners.
The question about partnerships and ecosystem at large is interesting because some of you mentioned that you have roots in academic research. Some of you are incubated within or have investors that are corporate ventures, and where you have customers as well that are big industries. Well, I'm curious about the integration of your solutions within the larger ecosystem. So some of you talked about garbage in, garbage out. You don't have your own assets as startups. A lot of the customers you work with have their own data, either that comes from industrial assets or from their IT systems. How do you integrate with that? What are the roadblocks that you faced, and how do you work around those?
Yeah, that's a tough question. It's instrumental, obviously, to have customers and users inside the ecosystem from day one. And that's actually what we did at SOMP. We had a users club. Funny enough, we had a users club before we had a product. So we had no users, and yet we had a users club. And that's how we defined the product with the industry. So it's 5 industrial players who are now all our customers. But that's how we define that, because, as you said, trying to build a product when you're in your ivory tower, not understanding the field, doesn't make sense. There's a strong chance you're going to build something that's beautiful for tech people, but doesn't solve any real-life problem. So involving users who have the real day-to-day problems and will use your software or your solution, whatever that is, at the end of the day, I think is crucial. So the ecosystem is here for me, not just to help you, but to define exactly what you need and to define the product.
Sure, I think for us, flexibility has been key. So we work with a whole range of customers. Some of them have very sophisticated IT teams. They know what an API is. They have digital records of their flow and all of that. Some folks we work with, for example, in Alaska and in parts of Africa, they don't have information. They definitely don't have IT, and we still want to be able to serve them. So the ability to have a flexible solution where you can meet folks where they're at has been challenging, especially for a tech company, but is something that's important to us to be inclusive and to serve as many folks as we can with helping them manage their water.
Because I'm sure you have stories around integration.
Yes, certainly. The benefit of using drones and robots to collect your data is you set the parameters and specs, and hopefully it comes out standardized, but definitely not the case most of the time. I think one of the important things, tying it back to Raptor Maps and also integrations with larger customers and their AI tools, is having clean, standardized data at the base plate, right? So if that data isn't standardized, when you extrapolate that across regions or across sites, it becomes infinitely harder to do any sort of analytics on top of that. So that's why it's just so critically important at the base layer or at the module level, as we do, to have that data standardized, cleaned, ready for use to whatever way any of our partners would like to use it.
Something that we realized really early on is that we wanted to be able to serve as much of the market as possible, and recognizing that in most countries, 90% of businesses are SMEs. We wanted to make sure our solution was easy to use for any manager. So they didn't have to have expertise in energy management or sustainability to use our platform. And we actually just went through a pilot, an agri-food pilot in Canada, right from the farm to one of the biggest grocery retailers. And we had users of all sorts using it. And that really, really resonated with us, that we really had limited questions from our users along the entire value chain of what type of data are you looking for, or what does this information mean? So it feels like we really hit the mark. Right now we have, it's a manual entry, so it's a survey-based entry, but we will be building out CSV upload, especially for companies with a lot of facilities, big fleets, and we're also building out an API strategy so that we can connect directly with their ERP or accounting platform in the future.
So to follow on from that, Don, has there been any big surprises for you when you're working with clients about how advanced or not advanced perhaps they are in a tech perspective?
Not yet. We've just gone through our first pilot, so we do have sort of a limited feedback. I think one of the learnings for us is that most companies know how to get the data that we're asking for. Most of it is, you can get from your invoices. So if you do your taxes every year, you can basically fill out our survey. So no real surprises. I would say what we've learned most is that customers are asking for, can I add more data? Can we get more insights? Can we add different features? And so that's really interesting to us, because they don't. Our current solution isn't a barrier for them. They actually want to add on features and get more insights from it.
So I might ask another general question from the panel. Emerging trends. What are you seeing that you're excited about in relation to how technology and emerging trends in tech could impact your business, or more broadly, sustainability and environmental topics?
I can share my dream and my vision about AI and tech in general. And I think this panel, being part of NG, is a great example. What you can see here is amazing tech at local scale. We talk about existing facilities. Here we have hydropower and water. Here we have solar and so on. But the future for me, whether it's in 5 years, 10 years, 20 years, we'll see, but it's a global optimal. Here we solve local optimal, but what about a model that takes everything into account, into the entire energy mix, into a global model that solves the actual problem of, okay, how do I solve this problem? Because the energy of tomorrow is not one source of energy centralized. It's a big mix of many different energies, very distributed, and we have to solve maintenance. We have to solve the type of mix we want. We want to have business intelligence. So I dream of a global model that aggregates all these local models that we're working on. So I think we're really at the beginning of the journey, and that's the moonshot for me.
Following that dream, I get a little bit scared, because I see what our energy sector is facing, especially in the US. We have, and I think in Europe it's true as well, we have really aggressive targets by 2025, by 2030, which is, tomorrow. and we're trying to remove those base loads that have been there for a while, and it's all good. I'm all for it. I think we're all ready for it. The question is, how are we going to keep that reliable grid? How are we going to make sure that we're providing power when we have lost some of those dirty but yet reliable sources? And so I'm excited to be a part of that by helping the hydropower industry be that step up and be that base load. It's also a little bit intimidating because I think as we move to the wind and solar, more technologies like what Raptor Maps is doing as well are needed. And are we all going to come together at the right moment so that we can be ready when that sort of switch hits? And what kind of challenges are we going to have in that transition? I think is still something that I'm hearing from a lot of customers. They're not quite exactly sure how it's going to go, and they're the ones who are providing your lights and your phone chargers and things like that. So excited to be a part of it, and also a little bit nervous to see how it's all going to go down with the timing.
It's fair. It's a good mix. Nervously excited. Gus?
Oh yeah. U.S. anecdote. I'm very excited for transmission lines to continue to be updated so they can handle our capacity. But that's definitely U.S. specific. But generally, when you're looking at solar and just the energy transition as a whole, just the pace of innovation is truly astounding. So, small anecdote from solar: almost every single year, large customers such as ENGIE or other operators have to analyze what panels they're going to use for their deployments that year because the technology has improved that much year over year. And in parallel to that, analytics providers such as us or robotics providers alongside us have to then accommodate those changes as well. So every year it's just a new evolution of what technology is coming out, what does that look like in our models, are issues displaying the same? If not, what's the power impact? So just really exciting to see the innovation happening and then how that downstream affects us.
I think for me, what's so exciting is that we're finally starting to see a sense of urgency. We've been talking about this for so long, and now we're starting to see all kinds of pressures come to bear, whether it's regulatory, customer pressures, banks tying lending terms to your sustainability. I think we're finally starting to make that transition towards from the why to the how, and I think it's a really exciting time to be in this space, so it's great.
A lot of the things you're saying are resonating with us at NG in terms of flexibility, in terms of decentralized assets and production, more consumption means, and focusing both on electrification and gas usage, for example, could be one. Also, the anecdote you shared in terms of collaborating potentially with or making partnerships with so-called competitors is interesting because it's a question we ask ourselves: what are the topics that we should work on at NG? Given that the market is evolving very rapidly, there are solutions coming up that are very advanced in terms of research, moving on to startups, moving on to real products. So what are the niche aspects that we can really bring value and differentiate ourselves and contribute positively to create an impact on the energy transition? So thanks for this very rich discussion. I think it's very interesting that we have a few startups that are very focused on operational field work with different energy sources, hydro, solar, assets, and digital twins. And we've got also a startup that's more BI related, trajectory and strategy based. So thanks a lot for your insights. Very rich discussion. Any questions from the audience?
Thank you, Frédéric from MIT. I have two questions. So it's also for NG. I don't know who can answer. The first one is the European data center. I saw it this morning. Capacity was supposed to be going from 4 gigawatt for Europe to 20 gigawatt in like 3 to 5 years, all because of AI and everything we're doing, and it's all renewable. So can we support it? Can we raise the capacity, to 5x? Is it 5x? Yeah. And the second question is, when it's a dam or local energy creation, it's easier to prove the renewable criteria of the energy source. But when we start putting it in the grid, how do you guarantee, how do you make it for generation? How do you prove that it's still renewable, you know?
Tough questions. Does anyone from the panel want to answer before Mihir and I can respond?
I think Angie has to answer that one.
I think so too. You start.
Okay, so on the first question about data centers, I think the 5x or 4x in terms of energy consumption for models might not be a linear growth. I think there'll be, it's a bit what we thought about, in the semiconductor industries a few decades ago in terms of, the increase in power would increase energy consumption on chips, and would that be sustainable? There were other advances in technology that meant that we could still increase power and processing power without the correlation with the energy needs that was linear. So I think there'll need to be advances in the energy provided to data centers and water cooling and other systems that are required for the kind of capacity that we will need for powering the whole AI algorithms and models that we will have in the next few years.
Yeah, so I'd add to that and say, necessity breeds invention, and I think what we're seeing is when there is huge calls, like data centers now have from a power perspective, we're seeing lots of things move at once. So yes, our capacity is growing and we are investing in more generation, but we're also seeing other players invest in reducing the amount of power required by processing units and changing the way that we cool data centers. So I think what we think of now as being a 5-fold increase in the near term may not actually be 5-fold by the time we get there because of the multiple layers of technology change. And the second part of your question around knowing what mix is in the grid from renewables and from a sustainability perspective is a really, again, another interesting question that we are seeing that some parts of the globe are doing this better than others. And that's one of the advantages of being part of ENGIE is we're present in over 30 countries. And in some parts of the world, we are already seeing that very specific link from generation right through to usage. And yes, it's all the same electron in the grid, but with real-time data and with very clear chains, value chains that have now been mapped and monitored, we can actually make that link, and we can be comfortable, but also very bold in asserting our want for that kind of mix in the future.
I just wanted to add to the first question. Something AI is really a hot topic right now, and sometimes we don't fully grasp the potential negative externalities or unintended consequences associated with AI. And large language models are notoriously energy intensive. And so that's why we actually went the route of a domain-specific LLM, because we could tailor it to reduce the amount of energy that it takes to actually gather that data. And we also were really cognizant that it's about data quality over data quantity, and also developing your algorithms for the key drivers. You can develop really big algorithms, but making sure that they only harness the key drivers is one way to reduce the energy intensiveness of some of these models.
Any other question from the audience?
Yes, hello, Jérôme Marquet from Orange. Quick question on how you plan as maybe NG Digital, so maybe for you, Andrea, to leverage all this innovation and this ecosystem around you, because it's moving so fast and you have to deliver products, as you said in the beginning. So what's the game plan?
If I told you, I'd have to kill you. No, I think the game plan is evolving, but our game plan, certainly along with the part of the business that Mihir is from as well, is to place a number of bets and to work with startups on how that they can achieve scale most rapidly. And that's what we're good at, industrialization of process and scaling up and standardization and all of those things. So for us at the moment, it's about making a link between lots of things that are very future focused and how we can bring that back and change the way we do business so that we can leverage these great ideas and these solutions. And it's hard, is the short answer, but it's actually the game, which is to try and bring a digital lens to NG globally and say there's a different way of doing business if we leverage this technology. And you see it time and time again where, you know, new tech comes out and we try and force fit it into the way we work today, and you don't get the benefit. So we are that link between fresh new ideas and technology advancement and a business that is scaled and industrial.
So we'll conclude this panel. Thank you very much, Laurent, Laura, Gus, Don, and Andrea for this very interesting discussion. Thank you to the audience for sticking with us. I'd like to thank MIT Club of France, who's co-organizing this Powered by AI sessions, as well as Techstars Sustainability Paris, who collaborate with us on this session. The next session for Powered by AI will take place on the 25th of June at NG in La Défense. For those of you interested in ethics and regulations, we'll have a panel speaking about that. If you're interested in getting on the mailing list, you can flash the QR code over there. Thank you very much.
Thanks, everyone.